How's it going there, all you mathematical minds? This is Mr. Longo here, and we are going to talk about complex numbers in this video. By now, I'm sure you've heard of all sorts of different number groups, such as real, imaginary, complex, rational, irrational, your natural, whole, and integers. The complex numbers basically is a set of all possible numbers that are both real and imaginary. So, until now, you might not have ever known what an imaginary number is. And we're going to start out by telling you that 2 squared is 4, which you are aware of. And then we have another one like negative 2 squared, which we know is still going to be 4 because a negative 2 times a negative 2 is a positive 4. But there is an imaginary number that can be squared and will give you a negative. And his name is I. So if we were to take I and square it, we would have a negative 1. And I is your new number. I is your imaginary number. So it's one of those letters that's going to represent the same thing every time. In this case, I is an imaginary number. And imaginary numbers are sometimes kind of difficult to work with because in the real world, they really don't exist. They're imaginary. So we still can do a lot of different math with them. So for example, back in the day, you learned how to take the square roots of numbers. The square root of 25 has always been 5. The square root of 12 was a decimal, but you learned how to simplify radicals and you would get 2 root 3. And if it couldn't be simplified, you would just leave it the way it is. Now, if you have absolutely no idea how I got 2 root 3, this video is a little bit too far advanced. You need to go back to learn how to simplify radicals first before you spend time on this video. But back in the day, you were always told you cannot take the square root of a negative number. And in many ways, that's correct in a real world, but in an imaginary world you can. So if we were to take the square root of a negative 25, we have 5i. So it's 5 imaginary. And the reason we can actually do that now is because if we were to take 5i and square it, 5 squared is 25 and I squared is a negative 1. Okay? So I understand it's kind of difficult to think about, but you'll get used to it as we go. So to simplify the square root of a negative 12, we would still simplify it just like we would. We would get 2 root 3, but we would get 2i root 3. So whenever you have an imaginary number when you're simplifying a radical, it goes in front. So this would just be I root 7. So the negative comes out as an I, and then you would just simplify the number just like you have in any other topic. Okay, so common ways to write a complex number is this way. This is a complex number standard form. And A is your real number, if there is one. And B, I for your imaginary number. And that's how you write a complex number. It goes real, then imaginary. So we can work with a bunch of different expressions, just like we would work with a number, because I is a number. So we can still add it, subtract it, multiply it, and divide it. Dividing is going to be a little bit different, and we will explain why in a minute. So to start out, though, it's just like combining like terms when you're adding and subtracting, because we would just combine our like terms. 3 plus a 7 is going to give us our 10 still, but now a 2i plus a 6i would give us an 8i. So we can still simplify and kind of treat it like a variable. In number 2, we're subtracting. 3 minus 6 is still going to give us a negative 3. And a negative 4 minus a negative 7 is going to give us a positive 3i. Remember, minus a negative turns into plus, so a negative 4i plus 7i is going to give us positive 3i. And we're done. We can't do anything else with these. Once we multiply and divide, we're going to have some multiple steps to do. So for this, we would just FOIL it or multiply it, double distribute, whatever you call it. So we would just say 3 times 2 is still going to give us our 6. 3 times a negative 3i is going to give us a negative 9i. And then we would work with our 2's. 2i times 2 is going to give us a 4i. And 2i minus 3i would end up giving us a negative 6i squared. So remember, I is a number, but when we're working with it, we can treat it like a variable, just like x times x is x squared. And then we just have to combine like terms. So we would have 6 minus 5i plus 6. Now you're probably wondering, where did I just get the plus 6 from? Well, remember what I mentioned at the beginning of the video. I squared is a negative 1. So a negative 6 times a negative 1 is a positive 6. Okay? So then we would actually have 12 minus 5i, and that would be our final answer. So when you're working with i's, that's what you want to do. The next example is different. Okay? So there's this rule. And the rule is that you're not allowed to have an I or a radical in the denominator. Don't ask me why, because it stems back from many years ago when there weren't ways to divide by radicals in a calculator. And everything was done by hand back in the day. With modern technology, it kind of can go away, but it hasn't yet. So until it does, you've got to know it. So to get rid of an imaginary number, something like this in a denominator, what you need to do is multiply the top and bottom by what is known as a complex conjugate. So let me just first tell you what a conjugate is. Watch this. So let's just say that we had x plus 2 and an x minus 2. Notice they're the exact same thing, but we have a different symbol in between the two. If we were to FOIL that out, we would have x squared plus 2x minus 2x, and then a minus 4. And then these guys would cancel. When we're doing that with i's, it'll make the I go away in the denominator. So a conjugate for this would be 4 minus 3i that we're going to multiply to both the top and bottom. Now remember, that's just a fancy form of 1. So if you were to FOIL the top, you would have your 12 and then minus 9i plus 8i minus 6i squared, which would simplify to 12 plus 6. Remember, this guy right here is plus 6. So we would have 18 minus I. But now, watch what happens when you FOIL the denominator. 4 times 4 is our 16. 4 times a negative 3i is going to give you your negative 12i. But now 3i times 4 is going to give you the positive 12i. Like I said, that will make those middles cancel. Now, how are you still going to get rid of your I? Well, once we do 3i times a negative 3i, which is a negative 9i squared, again, I squared is a number. I squared is a negative 1. So negative 9i squared is technically just a positive 9. So we would just have 16 plus 9, which is going to give us a denominator of 25. So 18 minus I over 25 would be your final answer for this question. Now, you're supposed to know how to do this by hand. So I'm going to avoid telling you how to do this with your calculator. But I'm going to tell you that you can do it with your calculator. It's called second decimal. So if you're using a TI-83 or a TI-84, try second decimal, see what happens. Okay? That's my little secret of the day. All right, y'all, this is Longo, and I'm out. See you, bye.